Okay, welcome to another Orbiter 2010 video, and this video is going to be a continuation in the Moon to Earth Gravity Sling out to Venus video series that I'm doing, whatever you want to call it. In the first few videos, we had to, just spend a lot of time setting things up, and setting up this mission is 95% of the work. Once the setup is done, the execution of the flight is pretty simple. There's a little bit more to do once you lift up off the moon. If you just do like an Earth to Mars plan, basically once you're in orbit and you complete the injection burn, it's done. I mean, for all intents and purposes. Once you're really comfortable with Orbiter, actually carrying out the plan to go from Earth to Mars is really simple. And in most cases, you'll find once you're really familiar with Orbiter that you spend all your time thinking about how to set up the mission and all your time planning the mission. And once you get good at that, actually doing the mission is the easy part. But in this case, where we're going from the moon, dropping down to the Earth and doing that gravity sling and going off to another planet, there's still a little bit more to do even after you've done all the initial planning. When we do that drop back to the Earth, there's some things that we need to consider, as opposed to just warping time forward and we buzz by Earth and automatically do our burn and then off to our other planet. It's not quite that simple. So let's go ahead and switch camera views here. And in the last video, we completed the burn to go back to the Earth. So all we need to do now is fast forward time until we are out away from the moon and we get into the influence of Earth's gravity. I'm going to go ahead and press VW. Actually, I'm going to go forward on this side and actually, view the escape plan over here. I do want to keep track of my relative inclination. Let me do an adjustment here on the eject orientation, kind of swing that line around. To where we currently are, and where we currently are is basically right there. And we can kind of see too, if we swing it forward a little farther as we go forward, it improves. So the first thing again what we need to do is just get out away from the moon. If we press F1, we can see we haven't gone anywhere yet. So let's warp time forward carefully here at the beginning, 10, 100, kill some rotation, 1,000, just to get out away from the moon a little ways. Hit kill rotate. Now we'll go to 10,000. That'll get us away from the moon really fast. Now we're out around the sun. And if we watch here in Interplanetary MFD, we can see exactly where we are. That white dot, I don't know how well that shows up in the video playback, but that white dot is us. And when we cross that perforated line, we will be crossing over into the Earth's SOI. Let me check over here just to see again how our eject orientation is coming along. Swing it forward a little bit farther. And you can see, here it's 1 point, whatever it was up there, but by the time we get out to this point, it should be closer to 1 degree. So it just improves as we continue to go forward. So let's just continue going forward. We don't need to do any corrections or anything at this point. We'll do a kill rotation. Get out to 10,000. And I think 10,000 is sufficient. I wouldn't go 100,000 from the Earth to the moon. It's just too quick. And as soon as we cross over into Earth's SOI, we'll go back to real time. And there we are. And we now have more data to work with. So again, make sure we're on view escape plan, and let's swing our eject orientation around so it's over our current position. And actually, let's also go to view setup and scale to view target. That way when we do when we're looking at the escape plan and we can see that white line, we can see where it's at a lot better. Okay, so currently we are, what is our inclination here? 0.2351. So I'm not going to be fuel efficient since we're in the Earth's SOI. I'm going to use Prograde Autopilot, hit time warp to get over to that point, get the vessel oriented more quickly. And I like to be in this position when doing various mid-course corrections. I like to be oriented at least in some direction that I feel makes sense, either prograde to the sun or prograde to the Earth or prograde to Mars or wherever we're going. I don't really like to be off in my orientation because when you're prograde, then lateral this way is lateral, and lateral that way is lateral, and up, down, and forward. It all works how you think it would work, but if you're off in some weird orientation, then you have to think, well, if I press forward translation, since I'm pointed this way, it's actually going to be a little bit lateral, and it's going to be a little bit up, down. It's not actually going to be forward. So it helps me to just have the vessel positioned more like this. Now, again, our relative inclination here is very slight. What I'm actually going to do before I do any correction at all, I'm just going to warp time forward at a factor of 100. And it's coming down. So that tells me that I may not really need to do any correction yet. Let's actually go forward a little bit farther. Let's bring the PET down to 60,000 and see what happens. See the relative inclination continuing to come down. Okay, now we're at about 65,000. So let's get our white line around here. And again, as we went forward, we could see that the relative inclination, it's trending downward. It's getting better. So there's not much point in trying to do much of a correction yet, because if we bring it all the way to 0, then it's actually gonna get worse in the other direction. So let's just warp time forward by, again, we'll just cut that number in half. We'll go from 64 to 32, and we'll just watch the relative inclination, see what happens. See, it's continuing to go down. Okay, let's go back to real time, straighten out our white line. And let's cut the number in half again, and then we'll see where the relative inclination is at that point. So let's go down to 15. Okay, back to real time. And as we get closer and closer to the Earth, the relative inclination will come down by less. So by this point, we probably want to do a little bit of correction. So let's switch to translation. And we don't have our bubbles. Why don't we have our bubbles? On the line of nodes, there's usually a filled-in bubble and an empty bubble, and I don't see those. Let me switch, out of curiosity, over to setup, view, yeah, craft. Now we can see them. So there's actually, you don't have to guess which way to translate. If you can see these bubbles, the one that's filled in means you need to translate normal minus. If it's not filled in, which is the case over here, and that's the one that we're pointed at, then it's going to be normal plus. In other words, we need to translate up. So by translating up, which is the number 2, that's going to bring the relative inclination down. That's something you can do so that you don't have to guess. So you can see by pressing 2, it's bringing the relative inclination down. And we don't want to bring it all the way to 0 because, again, it is trending downward as we go toward the Earth. But we'll bring it down to, say, I'm kind of looking for when these numbers start counting down on their own. And we kind of overshot it there, I saw. We'll go with that. All right, now let's view back over to the setup, and we'll change our scale to view back to target. Because again, that lets us see where that line lies much, much better. And we are at PET 14,000. Let's go down to 3,600. Watching our relative inclination. Come back out of time warp a little bit early because it looks like it might flip on me. So let me check the eject orientation. And it's still counting down, so let's go forward a little bit more. Just warping time forward carefully, and it's going to flip. So let's stop the time warp. and swing it around. And you can see now it's counting down quite quickly. That digit there is counting down at about 1 per second. So that means in 252 seconds it's going to flip. And we're not going to reach periapsis for 3,926 seconds. So it's counting down a little too fast. So I actually want to add in a little bit of error. I want to put in, so I want to increase the relative inclination actually. Instead of bringing it closer to 0 in this point, I actually want to push it farther out. And what I would really like to have happen is I want to have the countdown here match the PET. So again, you can see that that's counting down about 1 per second. So 217 seconds and it's going to be 0 and then it's going to flip. So let's push it out a bit farther. Okay, I don't know exactly what that's doing for me. That's about 1 per second. So 5,000 seconds we're going to say, maybe. That should be more than enough. Now let's bring the PET down to just 1,800 seconds. And we're about 2,000. So let's check this again. Let's adjust our line. See how we're doing on the relative inclination. And it looks like that digit's counting down about 1 per second, but not quite. So that's 94 seconds, roughly. And we're still 2,000 seconds out. That's not enough time. So let's put in a little bit more error. Actually, I went the wrong way that time, sorry. A little bit more than that even. So that's 248. And that's not enough time. It's counting down faster than... Maybe that'll be enough. And again, it doesn't have to be absolutely perfect, but you really want to show up at periapsis when your relative inclination is basically 0.000 across the board, as close as you possibly can be. Let's get in a little bit closer, and then we're going to set up our ejection burn. Bring the PET down to about 1,200. About ready to flip. And that flip just means that you're perfectly in plane at that point. It's exactly 0.00. And that's fine, except we don't want that to happen yet. We don't want that to happen until we are a little bit closer to periapsis.
Rotation, translation.
Okay, so we're 1,200 seconds out. Let's see if we can time it a little bit better. Okay, that looks to me like that's probably 378 seconds, so let's go more. Something around here. This should be really close to that. All right, now we need to shift our focus, not worry so much about the relative inclination, and focus on how to set up the injection burn. We don't really need interplanetary map on this side, so let's bring up the course program, target intercept, set. And we need to make sure we're referencing the sun. And then we're going to target Venus, because that's where we're going. And we need to know the MJD for when we're going to arrive at Venus according to TransX. And it's a good idea to write it down because you might lose track of it on accident. So go forward on your TransX stage to stage 2 and write down the encounter MJD. And we've got 57321.2989, and we're done with TransX. We don't need it for anything anymore. Now on your on this IMFD, set the date to what you just wrote down, 57321.2989. And now just bear with me for a minute. I am still thinking about things here. Now we also need to bring up IMFD on this side, and we want the orbit eject program. And before we do that, we need to share the left side with the right side, and the right side's ID is 1, so we're going to put in 1. And then we want the orbit eject program. And instead of higher orbit, we need to link orbit eject with the course program. So hit plus, and now orbit eject is linked to this course program. Now we need to set our TEJ on this side to the time that we're actually going to do the burn. And since we don't know exactly when that's going to be, we can just kind of guess. We can actually start by zeroing out the TEJ and then set this to an adjustment of 1 or 10 rather, and then just press plus plus and hold it, and you can see this blue line. That's where we're actually going to do the burn, and we want to do the burn at about periapsis, but more importantly, we want to do the burn when the DV is as low as it can be. And even if we have to go past periapsis a little bit, that's fine. Let me go down to a 1x setting though now. And that's getting a little bit worse. Let's back it up a little bit. In a perfect world, you will arrive at Earth and you will do the burn when you are like 20 seconds before reaching periapsis. If you could put in all your velocity in a split second, then you would want to arrive at periapsis exactly at the moment that you're going to input all your delta V in 1 split second. But since you can't input all your delta V in 1 split second, we want to start the burn, you know, a little bit before we reach periapsis, do the burn through periapsis, and then finish the burn as we pass through periapsis. That's in a perfect world. In a non-perfect world where we aren't experts at planning, we're going to be off by a little bit. But it looks like our planning here was actually pretty darn good. Let me just go to 10x here. Yeah, we're actually pretty good here. Go down to 1x. And 399.4 is the lowest I saw. And you can see, maybe, I don't know if we can zoom in on this or not. Yeah, we can. You can see we're starting our burn just before we reach periapsis. So this is actually darn near perfect. And it was dumb luck on my part. I certainly am not that great at planning, but it looks to me, and I'll have to ask Dimitri actually, because there's actually a couple of other things to take into consideration. I believe this line here needs to also be like at your periapsis, but from what I know about setting this up, this is really good. The first couple times I did this when I went to Mars, I ended up doing the burn when I was like out here, so I was past periapsis, and I was starting the burn like out here. And I think another time I did it, I was over here. So arriving and doing the burn just before you reach periapsis is like, that's the perfect time. But anyway, I can't talk too much because we've only got 800 seconds until it's time to do the burn. Now we can actually auto burn this orbit eject. We can just BV and AB, but we want to use IMFD's map program to help us do even better. Actually, on that point, one other thing to check here before you commit to this plan is you want to check your EIN in here, and you can see that it's 0.08. We can actually adjust that a little bit on this side by changing our arrival date. It just did a 1x adjustment. We can either change the TIN or the MJD. We can start with the MJD on a 1x adjustment and just press plus, and you can see that actually made it worse. So go minus. That's actually worse. So plus and minus on the MJD is too much. So let's go to the TIN. This is a more, if you think of this as like the medium or coarse, like in Transx, then this would be more like ultra or hyper. But let's go to a 10x adjustment here. And let's just bring that EIN all the way down to 0.00. And I remember Dimitri telling me to do that, because that's like your off-plane difference. And if you have that to 0.00, then you've got a better burn. All right, that's pretty good there. Now, since we did do a little bit of change there, let me also check on this side to see if it has any impact on our DV, if we can maybe do a little bit better on the DV now. Okay, by going forward, that's not helping. Going backwards is helping just a little tiny bit. not much, so about there. So it can make a difference if your EIN's way off. It could make a difference, so you want to check that before you commit to the burn. Okay, we are done with the course program. What you want to do now, and this part really can confuse you if you're not careful, press menu on both sides and bring up the course program on the side that is not shared. Okay, so in other words, we have, I take that back, orbit eject. Bring up orbit eject on the side that is not shared. So we have orbit eject up over, we have orbit eject on this side, but this side's not shared. We want to bring up orbit eject over here, and the reason we do that is because the side that is not shared will retain its information after you unshare it. And this part really baffled me for a while, and I made this mistake so many times where I would leave orbit eject and then I would lose all my information. So basically, I guess a better way to say it is to just bring up orbit eject on the other side, you know, but just make sure that it's not shared. See, it's not shared, so we have orbit eject up on this side. Now on this side, we're going to unshare it, and we unshare it by using the same ID on that side, so 0. Now we want to bring up the course program on this side, and we want to go to Delta V, set, and we want to copy our orbit eject plan from this side over to this side. And this is pretty simple to do. You just go to the TEJ, press set, and type in that number, and you can see it's counting down, so you want to go like 630, then wait. Press enter. It doesn't have to be perfect. Now go down to the these variables, and instead of just putting in delta V as 397.0, which you can do, especially since our EIN is 0.00, you could definitely do that. But this number is actually a combination of prograde, you know, forward velocity, whatever this calls it, and plane change and inward and outward. And we can figure out what those three velocities are if we press page and then go to BV. We can see the breakdown. You can see that it's almost all forward. That's why we could definitely get away with just putting it all in as forward. But if we want to have the breakdown, we have it here. And we go set. We'll just put it in as 397. It doesn't have to be perfect. And you don't need to worry about the decimal points because we're going to be making adjustments here in a moment. So it's really just a waste of time if you fiddle with the decimal points. The plane change, set it, don't set it, it doesn't matter. We'll just put it in as 1. And the inward outward, you can leave it off or put it in, you know, -4, whatever. And you'll see here that it just doesn't matter to get all those decimal points because we're going to be making changes anyway. Now on this side, we need to share this side with the Delta V program. So page, share, and now bring up the map. And we need to, let me think about this. We need to reference the sun, target Venus. And actually, I think if you just press target Venus, it will automatically reference the sun. So I don't think you necessarily have to do the reference sun first, but as a matter of habit, it might be a good idea. Turn off the annoying auto zoom, turn on the display lines, press the page button to come over here, turn on the SOI, and turn on the plan. And I really wish there was a setting in IMFD where you could have certain defaults, where you could have the SOI on by default, have the auto zoom off by default, and so on, because just doing that stuff every time is ridiculous. Okay, and now page back over to you know, this set of variables, and we need to select Venus. So we have the sun's periapsis, the sun's apoapsis, and now we have Venus. And we can see that according to this plan, we would have a periapsis at Venus of that number, and that's not that great. We would get there, but it would require a mid-course correction of some kind or another. Now, we just do what we normally do. Hopefully, you're probably in familiar territory with IMFD at this point. We just have to work with the delta velocity program on this side in order to bring the PEA down to a number that we like, and the number that we like is usually, you know, 2,000, 3,000, or 4,000 kilometers below the surface. And we start doing that by adjusting time. And again, that's why it doesn't matter if you input all these exactly as they appeared in the Orbit eject program, because we're now making changes to it anyway. Make sure your adjustment's at 1x anytime you're adjusting time or prograde. If you have it at 10x, it's just going to be way too much of an adjustment. But we'll start with time. Let's see what just putting in a little bit more time does. That's making the PEA worse. We don't want that. Let's go the other direction. And simply by taking out a little bit of time, we're improving things. It's unfortunately, it is improving things, but it is also, unfortunately, it means that we're going to be doing our burn a bit earlier than we would like. So it wasn't quite as perfect as I'd hoped it would be. Let me actually page over and zoom in one level. There we go. Continue taking out time until you see the PEA reach its bottom point. And then you actually want to keep going beyond that a little bit. But this is what I was talking about. You can see we're actually going to be starting our burn. You know, actually it's pretty far back now. It's no longer really close to periapsis, so it's a bit unfortunate. The timing just wasn't that great. So we're down to 193. Just keep taking time out. And now it's bottomed out, but keep going with it. And we're overshooting now. We're going farther out in the other direction, and now we'll go to the prograde. And we'll make an adjustment here and see what we need to do to bring things down, and that's 244. Let's go back to time. Okay, taking time out now is not helping. Adding time in is helping. Okay, so I'll just keep going this way with it. That's preferable for me because I want to be closer to periapsis anyway. Okay, looks like we're getting near the bottom, so I'm going to put in maybe 2 more seconds. Now go back to the prograde and just put in a couple clicks of prograde and overshoot that way a little bit. Now back to time. And we'll overshoot this way just a couple seconds. Now back to prograde. And rinse and repeat. You know, same thing we always do in Transx here. Just go back and forth. You want to get your PEA down to at least 10 or 20,000 kilometers or 10 or 20 M. And then you can start working with the other variables a little bit. Okay, so in time, and now let me actually check the low point because I'm getting a little confused now on exactly what the lowest point is. So that's 50 M. Go back to time for a second. 49. Okay, now 50. Okay, 48. So let me actually start now with a little bit of inward-outward. And you want to, these need to be at a higher adjustment. A 1x adjustment on these isn't enough. Let me try to hurry through this so we can finish the setup here at least before this video needs to end. And check the plane change. Sometimes plane change, especially for Venus, can make a pretty good difference. And you'll notice I'm adding in a lot of plane change, but you'll notice the overall total isn't really increasing that much. Again, that's just the way the calculation works, and might even go to 100 at this point. Okay, that's probably about as low as we're going to get there for the plane change. Let's go back to 1x on here. And try another second. And then see what the... okay, now back here, and 1 more second. Let's try 2 more seconds, 3 more seconds, 4, 5. Let's overshoot a little bit. Now back to the forward velocity or prograde. And we're getting really close. Probably another second or 2. Okay, back here, another second. Okay, we're almost there. We could do this burn, but we'll try to get it below the surface just because we still have time. And what I'll do also here is I'll go ahead and press page and AB because we're coming up to the point where it's going to want to adjust the vessel. So I'm going to turn that on now to let it do that, but we can still work with the variables in the meantime. You can see now we're below the surface and it's trending. Looks to me like it's going out, so we'll do a little bit more of an adjustment. Plus, let's add in 1 more second, 2 more seconds, 3 more seconds. And there we go, we're now below the surface. But you'll notice here, even in just the last 3 minutes between the time that we are at right now and the time we do the burn, that number is going to change. I've just noticed that when going in toward the planets. It seems more stable when I go out toward Mars. The PEA that I end up with when I'm still 2, 3, 4, 5 minutes out seems quite stable, but I've noticed consistently in IMFD when I'm going in either from Mars to Earth or Earth to Venus that this number just doesn't hold quite as consistently. So we'll go ahead and complete the burn here, and then we will wrap it up for this part of the video. And actually, I'm not going to make another part because this is it. Once you get to this point, then going out to Venus is no different than if you were just doing a normal planet-to-planet burn. The whole setup is at the moon, and then when we come down here to Earth, and we need to transfer that plan from TransX over to IMFD. But once you've done that, the mission's over for all intents and purposes, and assuming, of course, that you know how to do your mid-course corrections to go from planet to planet, then the mission's over. I can see here the PEA is continuing to adjust, so what I'll do is I'm looking at that, and you don't have to really do it, but I might add in, like, one more dash of prograde or take out a dash of prograde just to kind of get it reset back there into the middle of the planet right as I'm coming up to the burn. And I'll watch too for which direction it's going. Is it going farther into the negative or is it going farther positive? And that can help me to make adjustments. Like right now it's still trending down, so I'm not going to worry about it. In fact, we can fast forward time, go over to the burn. But I will go ahead and finish up this burn here, even though we're now at 32 minutes. And we're only burning 421 meters per second to go to Venus. Of course, keep in mind that we had to get to the moon somehow to begin with, so it's not like an overall fuel savings. It's not free energy. But if you already had a base on the moon, then you could go from the moon to Venus, more cheaply. So let's turn off the plan. And we can see our PEA 1.5, so let's go to translation. We're already at translation. And with just a couple bumps of translation, we now have the PEA where we want it to be. So that is it. All you have to do at this point is warp time forward until you are, halfway over to Venus. Keep an eye on your PEA the whole time, and then just do mid-course corrections as necessary. I find pretty consistently in 4 or 5 flights that I've done now, all off camera, that the PEA, when I go from Earth to Venus, tends to hold pretty well. So you'll find that the mid-course corrections that you need are very slight. You can do it all with translation, just 1 or 2 meters per second. And by the time I get close to Venus, I'm still going to be at some negative number. So I'm actually going to end up bringing the PEA out to the surface at some point. So that is it. And if you liked this video, let me know down below. Again, I'm going to do a whole nother video on this topic. We're going to start over at the moon, and we're going to go through the whole process again because it's complicated enough that I feel it warrants at least 2 videos, if not like 3, 4, or 5. It's really a topic that needs to be covered in a lot of detail, in my opinion. Check the links down. Check the description down below, rather, for links, and I will see you in the next video.